Welcome to First Take Math with Brian. Today we're going to work with solved equations. Again, we're going to do this with modeling with Algebra Tiles. Again, you can find this on the website, Algebra Tiles, Algebra for All. If you just Google that, you should be able to find that website. In this problem, we have the equation x plus 2 equals 5. Our first step is to model this. So, in the equation we have what we call the left side of the equation and the right side of the equation. So to model the left side, I have an x and two ones. On the right hand side, we clearly have a 5. And notice how, when I model this, I did get my big equal sign here. I have x plus 2 equals 5. Our objective in an equation is we're trying to find the value of x that makes this true. So if you look at the problem, what number can you add 2 and get 5? Well, a lot of us can probably already see that, 3 plus 2 is 5, so our solution would have to be 3. Now, if we want to use strategies, one of the powerful strategies to figure out what x is if we can get x by itself, that'll allow us to find what x is. So our step 2 is add or subtract the number with x to both sides. So the part that's by the x, we want this part to disappear. And the only way we make it disappear is use what we call its zero pair. So if I have a positive 2, what I need is actually a negative 2 to offset that. But to keep my equation balanced, notice now it's no longer balanced. This side actually is smaller because I deducted 2 off of it. To get it back to balance, I have to do the same thing to the right-hand side of the equation. So now it becomes balanced again. Now to simplify this, we kind of see that this is a zero pair. That's going to go away. But also on the right-hand side, we see a zero pair that can kind of go away. And notice that we're left with x is equal to then 3, and that would be called our solution, x equals 3. So we have now solved the equation. The value for x is 3. Let's try another one. So we have x minus 2 equals 3. So what I see is an x, a negative 1, a negative 2. I need 2 negative 1s. And I need a 3, so I bring that over to the other side. And so now you can see that it is balanced, it's equal. Now what we're trying to do is figure out what number can you subtract 2 from and get 3. Well, if you think about that, 5 take away 2 would indeed give me 3, so the solution would be 5 if I'm doing it mentally. If I want to use the strategies, one of the strategies to algebra is, if we can get the x by itself, that'll help us find what x is. And since we have this negative 2 here, we want to make that disappear. And I'm allowed to use its zero pair to make it disappear. So I'm going to add 2 to that side. And notice how it's no longer equal. To keep it balanced, if I add 2 over here, I must add 2 to the other side. And therefore we have our balanced equation. Now to simplify this, notice how a 2 and a negative 2, that's a zero pair. So those guys should zero out. And notice now I'm left with x equals 5. And once you get x by itself, that's going to tell you what x is. X is equal to 5. That is our solution. Okay? Let's see if we can come up with one more. So x minus 3 equals negative 2. So to model that, what I see is an x, a negative 3, and on the right-hand side, we have a negative 2. So again, what we're trying to do is figure out what number can you subtract 3 from and get a negative 2. Well, that's a little trickier for me. That one, for some reason, I don't see that answer as well. So what I'm going to do is just use an algebra strategy and see if I can just get x by itself. So to get this negative 3 to zero out, I need its zero pair, which is going to be a positive 3. So if I put a positive 3 on one side, to keep it balanced now, notice how it's not balanced. To keep it balanced, I must also add a 3 to the right-hand side. Okay? Notice now it turns again to be balanced. And you can kind of see that 3 to negative 3, that's a zero pair. That is going to zero out. So those guys are going to go away. On the right-hand side, we kind of see that there's a 3 and a negative 2. So there's some things going on over here that can be simplified. So that negative 2 is going to take out 2 of the positives, and that's going to leave me then with a 1. So 1 is going to be the solution to this problem. So if you have 1 and lose 3, that is going to take you down to a negative 2. So that problem does make sense. So that's going to conclude my lesson on modeling solving equations with algebra tiles.